Let us go to the next part of chemical reactions of alcohols, that is their oxidation. So we are on to the last reaction, that is oxidation of alcohols. So on oxidation of alcohols, first what we get is our aldehydes or ketones. These aldehydes or ketones on further oxidation give carboxylic acid. When we talk in the reverse manner, that is carboxylic acids when undergo reduction, they give aldehydes or ketones. And when these aldehydes and ketones undergo reduction, they in turn give alcohol. This series must be known to everyone. Now oxidation can be carried out with the help of various reagents, which can be dilute H2SO4 and K2Cr2O7, or alkaline or even acidified KMNO4, pyridinium chlorochromate, popularly known as PCC, or pyridinium dichromate, more popularly known as PDC. And also we can use Jones reagent. Now moving ahead, let us have a look at oxidation of primary or 1-degree alcohol. So ethyl alcohol, when it is treated with dilute H2SO4 and K2Cr2O7, let us see what happens. First, let us see the reaction between K2Cr2O7 and H2SO4. This results in the formation of K2SO4, Cr2SO4 thrice, water, and most importantly, nascent oxygen. It is this nascent oxygen that is responsible for the oxidation. So ethyl alcohol on oxidation would give an aldehyde. In this case, we get acetaldehyde, and what comes out is water. This acetaldehyde on further oxidation results in the formation of acetic acid. Now one thing that you would notice here is that the alcohol that we took here had 2 carbon atoms. The aldehyde that we got has 2 carbon atoms, and also the carboxylic acid that got produced as the end result also has 2 carbon atoms. So in conclusion, we can say that 1-degree alcohols on oxidation give carboxylic acids with the same number of carbon atoms as in the alcohol. After this, let us move to the oxidation of 2-degree alcohols. Now let us take the example of isopropyl alcohol. When it is oxidized by the combination of dilute H2SO4 and K2Cr2O7, it results in the formation of a ketone, in this case acetone, and water is obtained as a byproduct. This ketone or acetone specifically, it undergoes oxidation with dilute H2SO4 and K2Cr2O7 to produce acetic acid and give out CO2 gas and H2O. So now we can see that the alcohol that we took has 3 carbons, acetone has 3 carbons, but the final product, that is the acid which we got, has only 2 carbon atoms. So we can say that in conclusion that 2-degree alcohols on oxidation give carboxylic acids with 1 carbon atom less than in the corresponding alcohol. This is a very important point. Moving to the next one, that is oxidation of tertiary alcohols. When we talk about tertiary butyl alcohol or any tertiary alcohol, they do not undergo oxidation easily. First, they undergo elimination reaction in the presence of CrO3 to lose water molecule and become isobutylene. It is this isobutylene which is oxidized to give us acetone, that is a ketone with 1 carbon less, because it gives out CO2 gas and H2O. So if you notice, the alcohol that we took here had 4 carbon atoms. The alkene that we got has 4 atoms, but the final acetone or the ketone that we got has 3 carbon atoms. Now this ketone further undergoes oxidation in the presence of dilute H2SO4 and K2Cr2O7 to produce a carboxylic acid with 1 more carbon atom less, because it is again lost in the form of CO2. That is, we get acetic acid, and our final acid or our final product has only 2 carbon atoms. We started with 4 carbon atoms in tertiary butyl alcohol, and the last one that we got in acetic acid is just 2 carbon atoms. So in conclusion, we can say that 3-degree alcohols on oxidation give carboxylic acids with 2 carbon atoms less than in the corresponding alcohol. So summarizing this, we can say that 1-degree alcohols give carboxylic acids with the same number of carbon atoms. 2-degree alcohols give carboxylic acids with 1 carbon less, and 3-degree alcohols on oxidation give carbon atoms which are 2 less in number than as compared to alcohol. It is because of this we can use this method to distinguish between primary, secondary and tertiary alcohols, as all 3 of them give different products. Also, an important note that PCC is called as pyridinium chlorochromate. Its formula is C5H5NH plus CrO3 minus Cl. PDC is known as pyridinium dichromate and its formula is C5H5NH2 twice into Cr2O7. This is a very complex. Now 1 degree alcohol when treated with PCC or PDC gives an aldehyde. 2 degree alcohols when reacted with PCC and PDC, they give ketones. Tertiary alcohol when reacted with PCC and PDC does not produce any reaction. Also, PCC stops the oxidation at aldehyde and ketone level and does not lead to carboxylic acids. So if you want specifically aldehyde or ketone from primary or secondary alcohols, one must use PCC because it's selective and it stops up to aldehyde and ketone level. So this was all about the oxidation of alcohols to give different products.